Hey folks, sorry for the delay getting things started today. Went out and just got delayed. Coming back, the traffic took longer than I thought it would. We'll get everything going here. I'm going to just clear out my environment, get everything set up, and I'm going to go through and just do some more Code Wars problems for today. Cool. All right. So again, we're just going to go through probably a couple Code Wars problems. If you're here for the first time, or if you're new to Study Hall in general, welcome. This is a place for you all to ask questions regarding Python, regarding our material, especially. If you have a question related to our material, from our material, you can throw it in Slack, throw your link to Galvanize Learn in Slack, and I'll be happy to take the question and go through it on stream. If you don't have a question, you just want to hang out, I'm just going to go through some Code Wars problems, and I'm going to kind of highlight, again, I'm going to highlight problem solving strategies, things like that. Talk about building tests and kind of how to work through Code Wars problems in general. Yeah. So the reason that I'm doing this is we always recommend, when people ask us, like, where do I go to find programming problems? There's a lot of good websites, but we just kind of default to Code Wars. It's just got a lot of problems. It's got a lot of, when I say problems, it's got a lot of challenges to solve, right? So there's plenty of good programming challenges to solve on Code Wars. So we always recommend people come here, but I think there can be, just a few kind of startup issues with it. So I want to just help kind of grease the wheels, as it were, and make things easier for folks to get started. So yeah. Anyways, so yeah, when you come to Code Wars, you're going to come to this dashboard screen here. This is like kind of the home page that it takes you to. I always come to the kata. I'll click on the magnifying glass and go to kata. And that'll bring you here. And here you can select the difficulty. This is really the only thing you really need to know about, is the difficulty right there. So the difficulty, the easier problems are the higher numbers, right? So 8s are the easiest, 1s are the hardest. So we'll just go with the easy ones, just because I'm focusing on presenting more a how-to on Code Wars than like getting into the nitty-gritty with the tough problems. So we'll just go through some 7s and 6s probably. Yeah, we'll go from there. Cool. All right, so if I want to select multiple difficulties, I can just I can just click on the one that I want. So if I just want 8s, and click on 8s. But if I want to select multiples, I just click and drag over the ones that I want. So if I want to do 7s through 2s, I could click on 7 and then just drag my cursor over until 2 is selected, right? So yeah, like I said, we'll just do 6s, 8s through 6s. All right. So from here, not much of a science to it. I've had a lot of people ask me, like, something like, oh, I want to practice something with dictionaries, or I want to like practice something with for loops specifically. I would say, like if you want to target in on like a concept, on a specific concept, um, Code Wars isn't necessarily the best for that. There are some some tags here uh, that are okay. I haven't generally used these, or when I've tried to, I kind of look into them. I haven't generally found these too reliable. So the way I think about it is, if you want to get practice, practice should look like practicing everything. Kind of practicing everything in context. And Code Wars, I think, does a pretty good job of that. If you want to like dive in and explore a very specific topic, I think our material is actually well suited for that. So, as an idea, one way you might approach this if you're new to learning Python is to kind of get the concepts from our material and then go to Code Wars and just have a place to do reps, basically just practice, solving problem after problem. Okay. All right, spiel complete. So let's just go through here, and I'll just pick one that sounds interesting. Last Survivor. Okay, that sounds interesting. See what that's going to be. Okay, so this says you're given a string of letters and an array of numbers. Oops, let me check this really quick. Okay, good. You're given a string of letters and an array of numbers. Okay. String of letters and an array of numbers. An array is a list. They kind of write these problems to be compatible with a number of different languages. What many other languages call an array, and what's generally referred to as in a generic sense in computer science as an array, is what Python basically calls a list. So we can read array as list. So you are given a string of letters and an array of numbers. The numbers or a list of numbers. The numbers indicate the position of letters that must be removed. Okay, this is something going on here. Cool. Let's just jump into this. I'm going to click train up there, and we'll jump in. Make sure that Python is selected. You've got like a bunch of different languages up here. Sometimes it'll be on the wrong one, so if you're looking at it and it doesn't look familiar, you might look and just change it to Python. So cool. So before I even get started, let's just take a look at what we're looking at here, right? So you've got your problem statement on the left here. This is also where your output window is. There's these little tabs. I can switch between the instructions, the problem statement, and then the output. Now this isn't really regular terminal output, but it is sort of an output for the code here. So what I'm going to do, I'll just copy the problem statement in like that, put it into a big multi-line string. Okay. And then I'm going to start, before I even get through this, I'm just going to start looking for things that I can make tests out of. So that's my first goal, is to just get the problem statement on site and start making some tests. So I can come into this lower cell here, and what I usually do is just copy in everything and paste it in. And then basically I'm going to look for every line that calls my function, and all I need to do to make a test is have a complete invocation of the function. All it needs to be complete is just, obviously calling the function by name and then passing in the appropriate arguments, right? So just an invocation of the function and then some expectation. And the way that these tests are laid out, we're not going to dive too deep into that because we're going to convert these into kind of a simpler print style test. Okay, so I'll copy these test.assert equals, change these out to prints, And from here, I'm going to just kind of break these out just a little bit. So these are going to be, I'm going to say exp for expectation, and I'll do this. Res for result. So expectation is what we expect it to give us. Result is what it actually gives us. Oops. Okay. I feel like I messed something up there. Okay, we'll just do this. Equals. There we go. Okay. And then our prints. We kind of messed up our prints here, but that's okay. So our prints, what I like to do is print exp equals res, and this is just going to be true or false. If it's true, it means my test is passing because my expectation and my actual result match. So if it's true, it means the test is passing, and if it's false, it means it's failing. And then I'm going to print my result next to that so I can see it. And if it's failing, I can see exactly what I'm getting that's not the correct answer. So, and that'll help me diagnose potentially what's going on. Okay. And then let's just get a little space. There we go. Cool. Just kind of group those up nice. Okay, so we've got a few tests, and we might even have a few in here. So these examples might give me something as well. So you can see we've got something that looks like code here, although not necessarily Python code. So okay, so aha, I see. Well, I leave that alone. So that's not quite I don't think this is quite a test as much as an explanation of the process. Okay, cool. So I'm going to stub out my function. I'm going to say def function name, and I'm just going to model the inputs here. We're going to take in, what did they call this? You're given a string of letters, text, and then an array of nums. Let's call it nums, which we'll just treat it as a list. And then I'll just throw in a return to remind myself to put in the return whatever we're going to return. Okay, cool. So I've done all of this before I've even read the problem statement. And, yeah, that's generally how I like to approach this. Just get the test written as best you can, and then you can jump in to do other things. And I just noticed I have this little artifact. I have this sort of dangling comma out here on these that was kind of left over from when I copy pasted it in. So I'll delete that, clean that up, and we should be good. Now I'm just going to run it. We're getting false. My tests are all failing, which is good. That's what I expect. And I'm getting none because I'm not returning anything yet. But this at least tells me, I don't have any, basically that I didn't, miss anything like this, where I just have some invalid syntax or something weird like that I didn't expect. Okay, cool. So let's jump in. Now we can read the problem statement. So you're given a string of letters and an array of numbers. Okay, got it. The numbers indicate positions of the letters that must be removed in order, starting from the beginning of the array. Okay. So the numbers, I'm going to say from the list. We'll just call this a list. I'll just select all the arrays and change them to list. Okay, so the numbers from the list indicate positions of letters that must be removed. So position by index. And in order, so we have to remove those in that order. Cool. So from the string. After each removal, the list of strings decreases. There is no empty space. Okay. Return the only letter left. All right. So notes, the given string will never be empty. That's kind of good because I like to think of these kind of edge cases. So this is basically saying like, hey, we're never going to throw you this curveball. Hopefully they make good on that. Most of the time, the way these problems are written, you know, if something's stated this explicitly, it'll carry through. But you know, sometimes they try to get extra tricky. Okay, and then the length of the list is always one less than the length of the string. That makes sense. There can be duplicate letters and numbers. If you like this kata, check out the next one, Lost Survivors 2. Okay. Great. So let's just get into this. So if I'm looking at this, now basically what I want to do is be able to like kind of think through one or some of these to my satisfaction, right? So if I'm looking at this input, I've got this string ABC. I'm expecting A as a result, and I've got this array with 1 and 1 in it, right? So if I remove the first index, that'll be removing B, and then if I remove the first index again, that'll be removing C. So we remove the element at index 1, the element at index 1, and of course that just leaves me with A. Okay, cool. So, I'm thinking we can maybe I can return text. I have a hunch about this. I'm just going to chase it out. Sometimes my hunches are wrong. Usually they're pretty good. I at least usually learn something. So if this doesn't go anywhere, I'll just delete it and try again. But my suspicion is if I do something like, if I can return text if I do something like text equals text, and then I'll just do some slice based on the indices. Some slice, and I haven't thought through this slicing logic yet, but you know we'll get to that. Then I'll say for num in nums. So I want to slice up to, but not including num. So we'll just say num, and then from there I want to start at num plus 1. I think plus 1. Something like that. I wonder if that'll just do it. Oh, right. I want to do plus like that. True. Look at that. All trues. A, B, Z, C, D. Cool. Well, glad that hunch paid off. Yeah. So basically, I just have to think of a way to omit an element given that I know the index of the element that I want to omit, right? So if I want to omit the third element, I just have to, or the element at the third index, I have to devise some system to do that for me. And what comes to mind for that, you know, and I'm looking at this problem and I'm like, okay, I just need to omit or remove um, an element, given that I know the index. So, um, you might have thought of text.replace, but text.replace only gives me, it'll replace an element if I know which element I need to replace. So I think about like, well, what information do I have here, right? Do I know the element that I want to remove? And the answer is not really. I can figure it out, but what I really have is the index of the element that I want to remove. But I guess I could do, I guess I could do text sub num. That might work. So if I did text equals text dot remove, replace. I was just going through this with a student today. How I always, nearly every time I go to use the replace method, I always try to use remove, and then forget that remove is for lists and replace is for strings. But that's okay. It's like a mistake that I've made so often that I just, like, I catch it, but I still make it every time, basically. So it's funny. Okay, so we'll replace that element with an empty string. So that, I think this should work as well. Nope. Looks like we got one pass, but the rest failed. So that's kind of interesting. Yeah. Oh, this says text. I wanted to do text, not text. txt equals text.replace. Now we got a little thing here. Now that's interesting. We got an index error. Which I think like, kind of weirds me out, but evidently at some point we're accessing an index that's out of range. So that does work. I didn't like mess up the test somehow. So I wonder, let's try that out. See how much I got through. Wow, okay. Index error. So this happens just right out of the gate. That's interesting. So it's happening, but it's only happening on this last one. Wow, that's really interesting. Well, at any rate, this solution isn't working. That's okay because the solution is. Cool. And let me see if I can think of a variation on this. This isn't so much translatable into a comprehension as easily, so we'll just go with this. Let's see if it passes. It does. Cool. Okay. So yeah, that's something I forgot to mention. I really strongly recommend, like, when you're going through a Code Wars problem, do all the work in your own environment, whether it's Replit or a local environment or even Jupyter Notebook or whatever you work out of and whatever you have running and you're comfortable with. For now, then do the work out of there. Basically, the reason is, like, this output window just gives you information on whether the tests were passed. But like, if you wanna like print something out or sort of do your own debugging or write your own test or something, you can kind of do that in here. But I don't know. It feels more natural and just kind of easier to do it, and it's more straightforward to just use your local environment. And then you have like full editor features that you're familiar with. You get to practice the environment that you're actually going to use and all that. So yeah. Anyways, once you're done, of course, you just copy paste into there, hit attempt, and if all your tests pass here, then you can hit submit. Great. Okay. So once you're done with that, you can just go through and look at other people's solutions as well, right? So here's somebody took basically a completely different approach than me. It looks like they're doing, they make a variable L is equal to this comprehension of x equal, or x for x in letters, which is the string. Now this is interesting because it's interesting that they used a comprehension there. I don't, maybe there's some really good reason to do that. I don't think there is, though. I think the thing to do is to just cast letters as a list, right? Because that's the effect that it's gonna that comprehension is gonna have. It's gonna, I mean, it's neat that you can do that as a comprehension. It's possible as a comprehension, but it isn't really necessary. You can just if you cast a string to a list in this manner, same result. So we can do L like this. Then this comprehension just acts as a for loop. Excuse me. Gosh. Acts as a way of repeating this operation, this list dot pop x, and then this returns L sub 0. And the reason for, well, excuse me, I kind of jumped ahead. The reason for the pop is that it removes an element given that you know the index. It takes x, again they're calling it x. I would have called this num in, or I called it nums or num in mine, but it's kind of funny they used x as a letter and then x as a number. I don't know. Different naming convention. It's whatever. Yeah, so for x in chords, x is going to be a number, and we're going to pop the element at the index corresponding with that number. And then return L sub 0. The sub 0 just means that it's returning the element in the list. The list should have, the list called L should only have one element in it, but we don't want to return a list with one element in it. We just want to return the element. So that's the reason for that. So yeah, it's an interesting, different sort of solution. Looks like here's a similar solution to mine. Yep. Yeah, that's kind of interesting. They're doing for I in range len chords, which is the array, the list, and then they're getting the element in the array, which is the number that corresponds with the element in the string by its index. So it's kind of circuitous to do I in range here, because you end up with an index that you use to get the element from the list, and that element is then used as an index in the string. So a bit of a juggle there, but it works. No, I mean, no shame in a working solution. So you can go through here. I'm not here just trying to like judge everybody's solutions. I actually think those, like if I actually have a lot of respect for when somebody has like a kind of a limited set of tools and they just make it work anyways. I'm like, that's cool, like no shame in a working solution. But yeah, you can go through here and you might see somebody approach it in a similar way, but they maybe did something a little different that you would want to do next time in a similar problem, or somebody took a totally different way approach to solving the problem that you could learn something from. So I think you learn a lot from looking at at other people's solutions as well. So I always recommend, once you solve a problem, once you get it correct, just take some time and go through and kind of give it a scour, look through there. But yeah, okay, cool. So let's go Let's go for another one. Oh, Last Survivors, Episode 2. Okay, well, now this is level 6, so this is gonna have, you know, a bit of a challenge to it. Okay, let's hit train. And let's just jump right into it. Okay. So it looks like the tests for this are quite a bit more cumbersome. It's alright. Same basic idea. The tests might look scary, but like I said, all you gotta do, I mean, I just go through and select, I'm just gonna select all this. Is valid, instance test fail, really, all I'm gonna do here is look for instances of the function that I'm actually going to write here, right? So basically, yeah, I'm just going to kind of create some space around these so I can see them, so I don't delete them by accident, and then just go through and delete everything that's not one of those lines. Okay. So it looks like they're all marked with user result. The user result right there. So just, oops. Dang, now I'm worried that I accidentally deleted one. Okay. Let's try this again. Okay, so I'm going to be a little more careful. Last survivors is valid. Fix, return, test, describe. So my goal is just to not delete anything that actually calls the function. Okay. Ugh. There we go. Okay. I still feel like I just deleted some of those. That's okay. We got 4 tests here. That's fine. Really, the you know, as long as you don't have 0 tests, you're okay. We'll just turn that to print. Turn this to print. Okay. Oh, the way these tests are written. Wow. These actually are more complicated than most tests in terms of the way they're written. So I'm going to go through and scratch out the expectations for all these. So I got to look for this ABAA string, and then it looks like X user result has to equal AC. Well, that's very interesting. Okay. So, I think I'm just going to write my own expectations for this. Because however these tests were written, I just don't want to deal with it right now. We'll just do this. Okay, so we'll say res equals this, and I'll say exp equals, for now I'll just do empty string just so that it's something, and then I'll do res equals exp res. There we go. Okay, let's just read through this and kind of go through, and we'll make our own expectations. And that'll help us kind of understand, think through this. Okay, so substitute two equal letters by the next letter of the alphabet. Two letters convert to one. Interesting. Okay, so AA converts to B, BB converts to C, ZZ converts to A. Interesting. Two equal letters do not have to be adjacent. Repeat this operation until there are no possible substitutions left. Return a string. So that's interesting that they don't need to be adjacent. So if we look at this, and I'll just do this, I'll say string, or we'll do text again. So if I look at this, I see a pair of two letters. Yeah. Interesting. Very interesting. Okay. I see a pair of two letters. The letters are Z, so I'm going to replace those two Z's with an A. Right, so I take these two Z's and I turn them into an A, and that gives me a next string. Okay, cool. So then next up, I'm going to look at, I guess, the first index again, and I'm going to see I see two A's, so I'll pop off both of those A's and I'll put in a B. Woof. Okay. And then I see B, Z, B, so I see two B's, so I'm going to remove both B's, and in the place of the first one, I'm going to put a C. Okay. So, is this... These are pairs. Okay. Well, that's very interesting. So first of all, I think I need to build in this, like, being able to determine what the next letter of the alphabet is. Now, you and I know this, but we'll get Python to do this. I'm just going to do ABCs as a variable like this, and I'll say ABC, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay. So if I look through this, let's think of how to do this one. So this one would be, I'll go through and write the expectations for this one. So this one's going to be, I see two A's, and so I'll take that, I'll do it like this. I'll take this first A and we'll delete those and we'll substitute with a B. Now I have two B's, which I'll substitute with a C. So I guess now that I can't do anything else, I have a CA. So that's been reduced as far as it can be. So let's make sure. Aha, interesting. So this is expecting a C. So I wonder, am I supposed to return something else? Huh. Or I guess maybe I'm supposed to replace the double occurrence first. Oh, so that's interesting. So contiguous letters seem to take precedence. So this would be different if I take that approach. If I take that approach, I'd get B here, and then I have A, B, B, and then I turn the B, B into C. Woof. Okay, so might just have to, this might be kind of an ugly solution. A, C. But we'll work through it. Or my first attempt might be kind of ugly, but yeah, okay, so let's see here. So I should expect a C there. For this one, I should expect C, and let's just check that. So ZZ turns into A, which gives me AA, B. This turns into B. AA turns into B, which turns this into BB, which turns into C. Cool. And then for empty string, presumably I'm supposed to return empty string. Yes, empty string. Okay, so given empty string, we get empty string. Then given this, our expected result is going to be this. And I just realized something. Perhaps, as I'm thinking about this, I think maybe this doesn't. I think I had it right the first time. Like that there isn't that precedence of contiguous pairs versus just pairs, just the first possible pair of a duplicate number. So I think this should return CA, and I think so because this assert equals is being, the result is being passed to fix, this fix function, and I remember just glancing at this fix function, and what it does is it returns, it sorts the, that's funny, it takes it, so it takes in the string, it converts it to a list and passes that list to sorted, which it actually doesn't need to do. You can pass a string directly to sorted, and sorted will return a list, but neither here nor there. So sorted returns a list, and then we rejoin that list back as a string. So that's why it says AC. So regardless of how I write this solution, whether it returns CA or AC, the way it's going to be tested in Code Wars is in its sorted form. So I think I actually do want to make I'll make a fix function like that, so that however I write this, I have a little bit of flexibility in the order this returns, because the way it's going to be tested is in its sorted form anyway. So we'll just call this fix, def fix. It's kind of cool. We'll take in text. I'll call it text again, and we'll return string.join sorted text. And like I said, they're if you're wondering why mine differs a little bit, they're casting text as a list before they pass it to sorted, but you can actually just pass a string directly to sorted and it works fine. It'll return the same thing either way, whether you convert the string to a list before or not, So we'll do fix there, and then I think for all these, if res equals, so for all these exps, expi, we'll say fix. So if, oops, maybe I want to do that. Yeah. And I think I'll just do my raw res like this too, just to see what's going on. None type object is not iterable. Ah, okay, well that makes sense. It's trying to sort text, which is coming from this function. We're passing in res here, which is currently not returning anything. So if we return a string, and it'll work. Hey, look at that. We got a test passing. Cool. That's the empty string test, so that's not that magical. Cool. All right. Let's jump into this. Okay, now we can kind of get started. We finally got our tests worked out. If it seems like it takes a while, it's like if you're having the thought like I just want to jump in and start coding, like I will say, like, I put the energy into testing, like making sure my tests are good up front for a reason. It's definitely not something, it's part of the process. To me, that is like getting in there and starting coding. This is definitely a meaningful part of the problem solving process to me. So I hope you don't, I can see it being like, oh, okay, well, I guess I'm not going to spend that much time on testing or something, but like I would encourage you to do that, and you might have to learn the hard way, which is fine too. But the tests are important to get those all handled out first. Okay, cool. So yeah, let's jump into it. So I'm going to make a little bit of an assumption here, and I'm going to say that contiguous pairs don't take precedence over what I'll call first pairs. So we'll say contiguous pairs. And what I mean by this is the first pair, what I'm going to call the first pair is this A at index 0 and A at index 2. So A0 and A2 are the first pair, whereas the first contiguous pair is A at index 2 and A at index 3. So A2 and A3. So that would be the first contiguous pair. So I'm just going to assume that contiguous pairs do not take precedence, that I shouldn't convert any available first occurrence of contiguous pairs before I convert just first pairs. So I'm going to convert on first possible pairs. And the reason I'm noting this is if I go through this solution and it doesn't pass all the tests and it's failing in a way that kind of alludes to like maybe that does matter, that I can know that I made this assumption, right? So sometimes I'll just like, if there's a kind of a complicated assumption, I might just take a note of it, and I might make 2 or 3 assumptions where I'm like, well, and when I say assumption, it's kind of a guess, right? I'm kind of like, I'm pretty sure it's this, but it might not be. So I just want to note that I am making that assumption, and then if something goes wrong, I have a place to come back and look and say like, is this the point of failure? You know, so I'll probably I may look at my assumptions first if nothing else just jumps out at me, right? So cool. All right, so yeah, I guess we can just start getting into it. So I think I wonder if I can just sort this and then do like reduce this down, but no, I think changing the order would be too drastic of a shift, and would likely, almost certainly, lead to just different results, unfortunately. Alas. Okay. What I want to know is like, what if I have possibly multiple pairs of something, you know? It's interesting. One thing that I'm really noticing here is, the things being made pairs of in this example are always involving the first index, right? So ZZ is the first pair and a contiguous pair. It involves Z0 and Z1. So that gets combined into A and reduced into A. And then A0 and A2, right? So again, that involves index 0. So it's kind of funny because I'm like, I'm so used to like, okay, I have to do some operation to a string of characters. So I think I'm just going to like iterate through it, but that's not going to work here. That's very interesting. So I wonder if yeah, I think I have to do some kind of while loop because I don't know how many indices I've got to do here. So I think I'll say while, and I'm not sure what the exit condition is. It's not clear to me yet. All I really know, and all that's really governing my decision around a while loop, is that I need to repeat some process, but I don't know how to yet determine how many times I need to repeat that process. So, and I'm not sure that it actually can be determined without just doing it, right? So I'm just gonna just do a while true, and presumably once we get into the logic, the point at which we should stop will become obvious, and we'll either write in a condition here or just put in a break somewhere. One thing is I have to reteach myself the mechanism for this every time. So one thing, it's pretty easy to convert A to B, right? I get the index of the element that I'm converting from the list, and then find the index of that in ABC string, and then just go to the next index. And that's an easy process for 25 of the 26 letters here. But when I come to Z, I have to go back to A. So I have to figure out what that mechanism is. It's So if I had a z, how do I the question here is how do I convert that z to an a, and that z is at index 26. So 26 plus 1 is 27. Excuse me, it's at index 25. 25 plus 1 is 26. And I want 26 to resolve as 0. So I think it's just mod. It's like the I'll just say the index mod 26 mod 26 the index, and it's not just the index, it's the next index, which is the index plus 1. The index plus 1 mod 26, which means if 26, if the index is 25 plus 1, that's 26. Gosh, I need to, oops, we'll do this. IPython 3, and then we'll say, so 26 mod 26 is 0. Yes, okay. So if we have the index equals 25, that's for z, for that string of z. 25 plus 1 is 26. Mod 26 is 0, which will give us a. Good. And that should work for every element. Whew. Okay. So I just need to bake this in at some point. So I'll leave this here as a note. I just wanted to kind of figure out that process because I know I'm gonna come up against it at some point. Cool. Okay, so it's just go down each one of these. So our first one is CA. So we've got to combine this A and this A. So how do we do that? We've got to find text sub. Let's just call this IDX. And I think I'll do an IDX. I feel like this is going to need to be a variable at some point, but I don't know when I need to advance it. That's the thing. That's the weird thing. So I guess I'll just say, you know, if IDX, if text sub IDX dot count, excuse me, that's going to be text dot count text sub IDX is greater than 1. So if there's more than one occurrence, then I want to combine it, and I want the combination to propagate at that index. As I'm thinking about this, I am thinking, like, you know, maybe I'm trying to keep this as a string, but there's some pretty heavy manipulation of this string happening here. So I might just want to do text lst equals list of text, something like that. So I'll kind of just keep this operation in list here. So I think what I want to do is I'm going to say print list. And I'm just going to say input. I'm going to say input after here. I'm going to call the input function, and that's just going to give me a break. I can hit enter, and it'll advance to the next loop. You know, I think I'm actually just going to put this input right up front. So I'm just kind of putting in my own breakpoint here. Okay, so we got an infinite loop situation for sure because we've got no exit condition. Okay, so if that's the case, I want to you know, now I think I want to use the replace method, which is part of a string. Okay, so I'm going to say, if that's the case, so if the count of that element is more than 1, I want to replace the first 2 occurrences. Now I'm going to come in here, I'm going to call help on string.replace, like that. And then there's this count variable, and that's what I was looking at, right? So we look at count is maximum number of occurrences to replace. So what I want to do is I want to two things. I want to replace the first 2 occurrences. That's one thing. So that'll be text equals text dot replace. And let's call this, let's call this lm lm equals, I'll call it le. We'll call it le. So le equals text sub idx. So we want to replace the element with, let's just do nothing, and we'll do the count. I'll say count equals 2. We'll do the first 2 occurrences. And then I think we'll do that until we don't have, until we don't have a duplicate. So I think this is, if this one isn't a duplicate, then we'll advance IDX. That's what's funny though, is we might need to go back to the beginning at some point. So SE, give me 1 second, folks. Got somebody just knocking on my door. Okay, sorry about that. Somebody came in and asked me something. Cool. So let's jump back into this. So else, I'm just going to IDX plus equals 1 until our element count is over 1. And what I realized, I need to do this mod trick, because if I get to the end, you know, I might have created some other duplicate in some other position prior to this. So I want to do this mod trick where IDX wraps around. So I think I want to do, I think it's IDX mod len of text, right? So if the length of the text is 4 and IDX is 0, so that should read 0 mod 4 is 0. Okay, 0. Oops. 1 mod 4 is 1, 2, 3, 4. That's 0. That's what I want. The maximum index of this is 3, right? So 0, 1, 2, 3, right? So once it reaches, and the IDX is equal in length to a multiple of the lower value in the modulo, then it wraps around to 0. So it goes back to 0. So I can just bake it in like that. The reason I'm testing it like this is sometimes with different operations like this, especially with indexing and slicing and things, like it's a lot of times you gotta like add one or subtract one, and I don't always remember where that is. You know, there's enough variation in this. I think it's not important necessarily to like have every situation memorized. Some situations I do have memorized that, oh, you know, it's clear to me that I have to add one in this situation or subtract one or whatever. But in situations like this, I'm like, okay, I just need to like think through this and test it. And, you know, so. Okay, cool. So I've got this working. So this is going to continuously give me the next element. So what I've got to do here, I have one more thing to do here, which is I've erased those, but now I need to actually accumulate the next element. So two things to do that. One is acquire the next element. The alphabetical next element, right? And then prepend it or add it into the location of index, actually. Yeah. Insert. So I might convert it to a list just to do the insert and then convert it back to a string. Makes me think I could abstract that process into like a string insert function. I think I'll do that. First things first, though. First things first is acquire next element. So acquire next element just means we have LE. We want to see what alphabetically what the next element is in the alphabet. So let me just check this: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Just checking for typos. We're all good. Okay. So this is where I've got to do this logic, and we'll say next element. Let's call it NXT LE. Next LE is equal to ABC dot index of LE plus 1. I think we're going to use that as the index of ABC. I think that's right. So we do ABC sub abc.index le plus 1. Yeah, so this is going to give me the index of the element. This will give me the next index after that, and this will give me the element after le. Okay, so let's make sure that that's going to do what I want it to do. I'm printing print next print next le. Okay, so next iteration. Replace takes no keyword arguments. Oh, interesting. I didn't know they were just disallowed. That's interesting. Let's see. Wow. I am just not allowed to pass as a keyword argument. Okay, well, whatever. Okay, cool. So that's B is the next element, and if we look, that's correct. I don't know if we're going to get something different. Yeah, we're probably just stuck in an infinite loop, but that did, at least that's proof of concept. Okay. So we acquired the next element. That's good. Cross that off. Get it out of there. Insert at index, which I mean IDX, and let's make a string insert function. So we'll just call this def string insert. We'll take in text and return okay, so we'll make it into a list, and then we'll say list.insert. So this has to take in text, it has to take in an element, and then it has to take in an index. The element will be inserted, so I think this is element index. And let's check this out here. We'll do help on, I forget the order of the arguments, dot insert. This is another one of those things where like I always need to, it takes the index then the object. Okay, I have this backwards. So let's do it. I'll keep it element. We'll do it like that. Okay, cool. So list.insert at the index, this element, and this says string insert takes in text, an index to insert, and an element to insert it, and then we will return dot join list. I think that will do it. Okay, so we have a string insert function. So string insert, and since this returns, I'll just say text equals string insert text. That's the string we're taking in. The element to insert is next element. And, oops, see, I did it that way. We're inserting it at IDX and next element there. Woo! Okay. So I think what I want to do here is just I'm going to print text. Now the trick is going to be like ending this while loop at the appropriate time. Oops. Oops. Typo. Okay, BBA. Let's look at this. Okay, so that A's got to be turned into a B, right? So let's step through this. So that's got to be, here's our first pair, is this A and that A. So this A gets turned into a B. Oh no. This A just gets deleted and we end up with BBA, okay. And then CA, cool, okay. Now we're just going to be stuck there because I haven't written the logic to get us out of the loop. Okay, so now I need to determine how do I know when this is over? Well, I know this is over, but I've got to communicate that to Python. So I think what I want to do is, like, I need some probably a Boolean flag to tell me that I've like gone through every module value within the length space of the loop without making a replacement. So if I make it through from index 0 all the way to the end, and I don't do any replaces, yeah. So I think that's what, if I do a replace, then that tells me I need to continue the loop. I need to build a mechanism that'll do that. That's the trick. So I could say, let me break this out. I don't want to break that out too much. I'll just use that as is. So I could say, yeah, okay. So if this idx mod len list equals 0, we're starting a new pass. New pass equals true. And then if I make it through this whole thing, I think it's this condition that I want to check. So if this equals 0 and yeah, changes made. If changes made equals true. So if we made changes, what would be a better name for this? Made changes. We'll call it made changes. So this tells us that we've made a change. So that's going to be true. So if both of those are true, then I think we're going to return. No. Then we're going to I think what I want to do here is didn't make changes. Wow, okay. This is very convoluted. Well, we'll just have to tinker with this until we get it. Okay. So if that equals 0, and we did make changes, let's say didn't make, let's call it unchanged. So text unchanged. So I gotta figure out where to put this. So we'll assume that it's unchanged. Okay. Now, so this is going to be the else. That'll be the else. So we need a starting state here. We'll start that at false. Okay. Whew. Now let's just see. I'm going to comment out my breakpoint, and false is not. Let's see, we've got to spell that correctly. Okay. String index out of range. Alas. Now that's interesting. Line 102. Oh, right. That's what I was saying about it's got to be that next index mod 26. I forgot the mod 26 part. That was that whole thing I did at the beginning. Okay. And it's still out of range. Do I need to, I think maybe I need to put parentheses around that. Integer division by 0. Now what I want to know is, yep, this is for that time when the string is empty. So I'm just going to catch that. That's an edge case. I'm just going to say if text equals empty string, return empty string. Cool. Whoa. Okay, we've got a lot of stuff. get rid of that. Okay. Well, this is kind of cool. We've got 3 out of 4 passing. That's not everything, obviously, but that's something. So let's see what we're expecting here. Looks like we've got a number of duplicates. You can see we're printing the fixed, which is really just the sorted strings. This I should call this string sort. We'll call that string sorted since it gives me back a string. So I can see that I have something funky with my exit condition, which honestly I'm not surprised about. So basically, I think what's happening when we reset to a new pass here, I really do want to do that. I really do want to reset this to true. We're going to assume that the next pass is going to have unchanged text. So I think this just has to be a different condition. Yeah. That's interesting. I wonder if this is what I want to do. If text unchanged is true. So I wonder if this is it. If text is changed is true, then we return text. So if we made it through if the index equals 0 and text unchanged is true, then we return text. That can't be. That's not going to be right at all. Maybe I want to do this when... Wow. Oh. I just ran it. I was just like, oh, I'll just save it here. I genuinely didn't think that was going to work. But it passed. It passed my last test. Okay. Well, that's something. Cool. Let's see if it passes in Code Wars. This is an interesting one. Give it a shot. I'm not super hopeful, but we'll see. Oh my gosh. It passed. It actually worked. See, and there's obviously a much cleaner solution, you know. So it can be done better. I'm sure if I read through these, I'd be like, oh gosh, it's obvious, right? You know, but I'm kind of a proponent of just like, you know, don't worry about it. Don't worry about putting together a perfect solution. The first time solving a problem, just make it work. I'm probably going to keep this page up just to like consult it just for fun later. And then I'm probably going to go like try to optimize this myself. But like what I have here, even though it is clunky, and I've got some comments in here that need to be cleaned up. Even though it's clunky, this is, you know, I'm not going to defend this as beautiful code or anything. It's kind of a mess, but even though it's clunky, I'm just going to like see if I can optimize it myself and clean it up and, you know, do my best to like, you know, minimize things. And what I have here is a proof of concept and a working solution, and then it's just a matter of like reducing redundancies. Like there's a few things here, right? Like I'm using this in multiple places. I could probably make that into a variable. I might be able to get away with just doing it in one place instead of this whole thing. I could probably make an exit condition, a proper exit condition here. So, yeah, something like that. And then once I do my best with that, then I'll go through and look at the other solutions there. Cool. All right. Well, I hope that was fun for you all. That was fun for me. I like being able to go through these challenges and just talk about how I'm thinking about them and talk about my approach, and hopefully you all find it useful as well. So yeah, let's see here. I didn't see anything. Let me check. I realized my phone kind of went off there. Yeah, I don't see anything in chat. I do want to remind you all, you are welcome. Please do feel welcome to post in chat and ask any questions that you might have. That is the primary purpose of Study Hall, to give you a venue to ask questions and have me help you with the answers. Obviously, for you all to help each other as well, not just me. But yeah, cool. I think I'm going to keep up this format. I think I want to do another Code Wars stream on Friday. Hear how people like it, and we'll kind of go from there. But yeah, feel free to reach out if you have any other questions between now and then. And you all have a great rest of your evening. All right, cool. Bye-bye.